Okay, hello students. We're going to continue with Unit 2, the chemical basis of life. So we can't have biology unless we have chemistry. So if you don't like chemistry, that is unfortunate because you still need to learn it. And thank you, Alio, for translating. Okay, let's start here. Why do we need to learn chemistry? So that we know what we are made from. What is the smallest unit we are made from? Does anyone remember the smallest unit of life is a cell? But what makes up cells? All life is made from atoms and molecules. These are the subjects we're going to cover. Number 1, all life is made from atoms and molecules. 2, atoms bond to form molecules and compounds. 3, water makes life possible. 4, buffers regulate body pH. Our goal is to understand how chemistry makes life possible. So when you are studying your notes and you find yourself getting lost in the lecture, come back and look for these outlines to help you organize our thoughts and your thoughts. Okay, matter comes in different types called elements. For example, here's hydrogen, symbolized by H. It is an element. Oxygen is also an element. What are elements made of, though? Atoms. Atoms are the smallest particles of each element. However, when atoms bond, we get something called a molecule. Molecules are atoms bonded together. One molecule is actually 2 or more atoms. Here's an example. If we bond hydrogen and oxygen, what do we get? Well, if there are 2 hydrogens, we get dihydrogen. If there's 1 oxygen, we get monoxide. What's the common word for dihydrogen monoxide? It is water. So de l'eau is water. I hope you also learned some English. There are 4 different ways of representing water. We can write out H2O, meaning 2 hydrogens and 1 oxygen. We can do it this way, in which we see the 2 hydrogens, the 1 oxygen, and we see the angle that's between the bond. Oh, I think I can circle. Cool. Okay. And then here's a different way. It's kind of a 3D representation. And this final way shows the parts of the atom, which we will learn about. You see the nucleus. We also see each electron. The electrons orbit the nucleus. The electrons are shared. That's how the atoms bond. Each element has different properties, and each element is represented by different letters. For example, the element carbon is represented by the letter C. Sodium is represented as Na. Wonder. Okay. Each element is symbolized by a different letter. So these elements on this page, I want you to learn their symbols. You need to know Na is sodium, Cl is chlorine, N is nitrogen. So either in English or in Creole or French, N is nitrogen. In French, we say azote. But in English, it's nitrogen, which starts with the letter N. Let's look at sodium. Sodium is a metal, and chlorine is a gas. This is the chlorine inside this jar. It's a poisonous gas. So these two things would injure you in their pure form. But when we combine sodium and chloride, what do we get? NaCl is salt. Look at hydrogen. Hydrogen is a gas. Oxygen is a gas. When we combine hydrogen and oxygen, we get a liquid. So, how can you remember these elements that you need to know? CHONP, chomp, you can call it chomp, and NaCl is just salt, the parts of salt. Okay. I'm going to try a different highlighter. Let's try a laser pointer. Ooh. Okay. The atom is the smallest particle of an element. For example, oxygen, O2, the thing we breathe, the gas we breathe, is made up of 2 atoms of oxygen. But what are these atoms made of? They are made of particles that we call subatomic particles. There are 3 types of particles: protons, neutrons, and electrons. Here is an atomic model of helium. So this is the element helium. This is the atom of helium. The nucleus is in the center and consists of protons and neutrons. The proton is represented by the plus sign because a proton has a positive charge. Neutrons are neutral, so they don't have a plus or minus sign. Neutrons are neutral. They are also in the nucleus. Surrounding the nucleus is what we call electronic sphere, the sphere in which the electrons orbit the nucleus. Electrons have a negative charge. So in this diagram of helium, I can see there are 2 protons, 2 neutrons, 2 electrons. A positive charge cancels a negative charge. So if we have an equal number of electrons and then as protons, we will have a neutral charge, because 2 positives cancel 2 negatives. This will be important to know when we talk about bonds. Okay, next slide. It's not scrolling. Okay. Each element has its own type of atom with a unique number of protons. So here is a chart. In English, we call it the periodic table. Each element or each type of atom, I can say. Each one is arranged by the number of protons. So we know that each atom has a different number of electrons arranged outside of the nucleus. Each atom has a different number of protons within the nucleus. So an element of hydrogen up here in the corner has 1 proton in the nucleus. And here we can see the electronic shell or the sphere. And I see this yellow dot represents an electron. So hydrogen has 1 electron that orbits the nucleus. Here's helium. How many electrons does it have? It has 2. Each of these squares shows the detail about the element. It shows the symbol that we use. So for helium, it's He. It shows the number of electrons in the sphere. We see 2 electrons. It shows the atomic number as this number 2 here, or sometimes you'll see a chart with it like this, the number 2. The atomic number is the number of protons. So this 2 written here or next to the He means there's 2 protons within that nucleus. Sometimes you will see the atomic mass. In English, we call it atomic mass. Here you see it, the number of the mass, which is 4. That's talking about the mass of the nucleus. And the mass, on the next slide, the mass is the number of protons plus the number of neutrons. So look at helium. 2 protons plus 2 neutrons. What's the mass? So add 2 plus 2 equals 4. And here on this first slide, here's the number of the mass is 4. They get that. So if you're given the atomic number of 2 protons, and you also know that the number of protons plus the number of neutrons equals 4, you just do math. Let me find my pen. So 4, so protons and neutrons minus 2 protons. How many neutrons are in this element? 2 neutrons. And Elio can stop and explain again if you need to, but we'll look at carbon and do that again. So here's a diagram of carbon. It tells me that there's 6 protons and there's 6 neutrons in the nucleus. I can't see them all because this is a 3D representation. I see 4 neutrons, but on the back side of it, there's 2 more neutrons. They say protons or neutrons. Okay. You can't see all the protons and the neutrons. However, on the electronic shell, I can see that there are 1, 2, 3, 4, 5, 6 electrons. What is the atomic mass of carbon? We add the number of protons plus number of neutrons equals 12 for the atomic mass. Let's go back and look at our chart. Oh, this chart doesn't have atomic mass. Okay. But I can say that 12 is the mass. Okay. On this chart, I can also see 1, 2, 3, 4, 5, 6 electrons. Here's sodium. This is a different way that it's telling us there's 12 neutrons plus 11 protons. Look at that. There's a different number. So its atomic mass is 12 plus 11 equals 23. How many electrons are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 electrons, and there's 11 protons. So what is the charge of this atom? Remember, we said positives cancel out negatives. There's 11 of each, then the charge is going to be nothing, neutral. There is no charge. I want to, so this is very important. The number of protons in an atom is always the same. It never, ever, ever changes. Carbon will always have 11 protons. The number of electrons might change, but the protons will always be the same. Helium will always have 2 protons. Oh, did I say carbon? Okay. Alio can fix my mistakes. 6 protons always, 11 protons always in sodium. Okay. Next slide. I tell myself to change the slide. Okay. Let's discuss the electronic shell a little bit more, because this will become important when we talk about bonds. Why do we have to talk about bonds? So we know how molecules attach. Why do we have to talk about how molecules attach to each other? Because that affects life. Okay, here's the nucleus right here. Doesn't matter what type of atom it is. Here's the nucleus that has protons and neutrons. This atom has 3 electronic shells or spheres. A way that we can think about electrons moving from shell to shell or descending down from shell to shell is to think about stairs. So a set of stairs, and this ball bounces down it. A ball bouncing down a flight of stairs can come to rest only on each step. It can't rest between steps. Similarly, an electron can exist only at certain energy levels and not between the levels. We can think of each sphere as an energy level. So energy, the highest energy level, next highest, and the lowest energy level. Highest, middle, lowest. So electrons can't stop in between. They can only stop on each sphere. And sometimes I'll call it a shell. This atom has 3 shells. The arrows show that energy is absorbed as an electron moves up in levels. So from level 1 to level 3, energy is absorbed. It takes outside energy to make this electron move from level 1 to level 3, just as it takes outside energy to get a ball to move from step 1 to step 3. So a ball is not going to move from step 1 to 3 on its own. You have to come over, pick up the ball, and it takes your energy to place that ball up higher. So now that the ball is in this highest level, it has energy to do work. We put energy into picking up this ball and putting it on the top level. But now in this highest level, the electron has energy to do work, or the ball has energy to do work. The ball on its own can bounce down these stairs. As the ball moves down to lower stairs, it loses energy. Or as an electron moves down to a lower shell, it loses energy. This will be important when we study respiration and photosynthesis. In this model, here's the explanation. The third shell has the highest level of energy in this model. Second shell has the next highest. First shell has the lowest energy level. And these figures come from your textbook, which should be on your flash drive, but you can also get a copy in the library. So hopefully the library is open. Okay, and now to explain this part. An electron can move from one shell to another only if the energy it gains or loses is exactly equal to the difference in energy between the energy levels of the two shells. So there's an energy level between 1 or 2 and 2. This electron moving from 2 to 1 will lose that much energy. And this is probably something that you'll have to go and read on your own and think about. But think of it as a ball traveling down stairs. Okay. Which elements are in life? There's 92 elements, or we can say types of atoms, that are found in nature. 4 elements make up 96% of your body and all life. So you have to know this. CHON, carbon, hydrogen, oxygen, nitrogen, or azote, right? Okay. CHON, how are you going to remember that? Chon. Just make up a word that you can remember. Chon. So how much of your body is made up of chon? 96%. That's a lot. We said that 92 elements occur naturally. There are 25 elements in the human body. 90%, how much of it is chon? 96%. What about the other 4? The other 4% of our mass consists of calcium, phosphorus, potassium, sulfur, sodium, chloride, magnesium. But there is a little bit more space in our body for 14 more elements. 0.01% of our body mass is made up of these 14 elements down here. Because we need only a small quantity, we call them trace elements. But without them, our bodies would not function. So they are essential. And they're down here. I won't expect you to know all of them, but I want you to know about them. If we don't have zinc in our diet, we will be unhealthy. and maybe die. If we don't have iron for our blood, we will be very unhealthy. Okay. So we've been seeing pictures of pure elements. Here's pure sulfur, pure phosphorus. But how come we don't look like this? We look totally different than the raw atoms and the raw elements. When atoms come together, they form molecules that act differently than the individual elements. So, for example, hydrogen and oxygen are gas, but when they're a molecule, they're a liquid. And most of our body, like most of the Earth's surface is made up of water. Okay. We're going to move on to our second subject, which is that atoms form molecules and compounds. So let's learn how that happens. For example, 2 atoms of oxygen make a molecule of oxygen. But what holds these 2 atoms together? Oh, and another example, a compound is 2 or more different types of elements bonded together, such as sodium and chloride. What do we get when these are bonded? We get salt. You will need to know this for your exam. And again, hydrogen and oxygen make water. So these will be easy test questions for you, right? If I ask you to write the chemical formula for salt, you will write NaCl. Okay, we're going to learn about 3 types of chemical bonds. Chemical bonds hold atoms together. So chemical bonds are holding us together. We will learn about covalent bonds, ionic bonds, and hydrogen bonds. Why do we even need to learn this? Because biological processes such as photosynthesis and respiration rely on how these bonds work. We need to understand the bonds in order to understand photosynthesis. Why do you need to know about photosynthesis? Because you're studying agronomy. You need to understand how your crops grow and how to improve their growth. So you need to know about how plants get their energy, which is through photosynthesis. Let's start with covalent bonds, which occur when 2 atoms share electrons. Let's look at the electrons on this oxygen atom. On the left are a pair of atoms. Oh, electrons. Sorry. I don't know how to stop and redo this. Okay. We are looking at the number of electrons on the electron shell. Electrons like to be in pairs, just like people or animals. We like company. So these 2 electrons are on this shell. They like each other. They're going to stay together. But over here, we have a lonely electron. We have another lonely electron here. So atoms make so how is this going to get another electron to make this electron happy? It needs another atom with single electrons on its shell. Electrons are most stable in pairs. Atoms make electron pairs by sharing electrons. If you share electrons, this is called a covalent bond. Oxygen and hydrogen combine through covalent bonds to make water. This is the oxygen atom with its 2 lonely electrons. Here's a hydrogen atom. Hydrogen has 1 electron on its shell. So these guys are going to share their electrons. Oh, but there's another lonely electron. So another hydrogen atom can come. Over here, we see the sharing. Remember, we're talking about covalent bonds. They share. There's 2 ways that they can share. There's non-polar covalent bonds and something called polar covalent bonds. We'll talk about the non-polar covalent bond. They share electrons equally. Both atoms will be pulling with the same strength. They're pulling on the electrons with the same strength. Atoms of the same element have the same strength when they are pulling on their electrons. Let's look at carbon and hydrogen and how they share electrons. So let me draw in this other shell. On this diagram, there's actually a shell here. Let me see if I can make this darker, because you're probably looking at this in a classroom with a lot of light. Okay, so here's the first shell of carbon. When I draw in the electrons, I draw 2 on the first shell. So, and we see the picture here. The first shell of an atom only has 2 electrons. So they're happy, they're in pairs. We know from our table that we looked at before, carbon has 6 protons and 6 electrons. So we need to put the other 6 electrons on this outer shell. And we arrange them like this. So they're lonely. They need company. That means a carbon atom can accept a hydrogen atom to make it happy. The hydrogen atom has only 1 electron. So how many hydrogen atoms can this carbon share its electrons with? You can share it with 1, 2, 3, 4. They are sharing electrons equally because all of the electrons now have partners. There's no tension. Everyone's happy. There's no jealousy. Okay. Let's talk about covalent bonds in which electrons are shared unequally. This is called polar. Like the North Pole and the South Pole are separate. They're unequal. Atoms pull on electrons with different amounts of strength. Oxygen will hold electrons closer to the nucleus than some other types of atoms. Remember, electrons have a negative charge. But hydrogen is a partially positively charged atom. So opposites attract. A negative and a positive will attract. Look at the outer shell of the oxygen atom. There are 2 single electrons here. So how many electrons from hydrogen can come? 2. We have 2 hydrogens that we'll share. These are called polar covalent bonds. Here is a molecule that has both polar and non-polar covalent bonds. Remember, covalent means share. This shows me that caffeine, the stuff that we find in coffee and chocolate and tea, has 4 nitrogens. It has 2 oxygens, and it has 3 of these carbon and hydrogen units. So how many atoms are blue? Oh, I gave you the answer already. Nitrogen. How many are red? How many are black? So actually, see here, they're showing this molecule in a different way. These atoms are black. There's quite a few black ones. 1, 2, 3, 4, 5, 6, 7, 8. There's 8 black ones. And here we can see carbon. There's 8 carbon molecules. So on this first diagram, the C, carbon, is actually shown. There's actually a carbon molecule here. And there's one here. At each junction, there's a carbon molecule. If you take organic chemistry, you will learn this more. They don't show the carbon. They assume that you will know at this juncture there's a carbon. So 1, 2, 3, 4, 5, 6, 7, 8. And that's carbon. And then here is a different way, a 3D model. Okay. So this is important to remember. Polar bonds form polar molecules. Each molecule has a positive side, and each has a negative side. So I hope you are learning this in your chemistry class. If you've had chemistry, this should be a review. If you haven't had chemistry, then this will help you in your class. The second type of bond we're looking at is ionic bonds. An ion is an atom that has lost or gained an electron. An ion has a positive charge if it loses an electron, in which case it is called a cation. An ion has a negative charge if it gains an electron, in which case it's called an anion. So a positive charge is a cation. Remember, this T is positive. So that means the other one, the anion, is negative. Remember that electrons are negative. So if it has more electrons than protons, it will be negative. Generally, atoms will lose or gain electrons if they can easily empty their outer shell or fill it to 8 electrons. So this is the outer shell out here. Let's count the electrons in these shells of sodium and chlorine, and I will explain how the shells are what we call filled. How do the shells get filled with electrons? First, we start with this inner shell, or the lowest energy level shell. We always start here. If there's 2 electrons in the atom, we put them here. And next, we start filling the second shell. We don't yet pair them up. We put them in singularly so that we have them distributed around the shell. So a carbon, remember when we looked at carbon? Where is carbon? Here. I'm filling first the inner shell with 2 electrons. Then I move to the second shell and fill it with the electrons. So in carbon, I have 6 electrons. Here is sodium. Has 1, 2, 3, 4, 5, 6. And then we start pairing up. Oops. 3, 4, 5, 6, 7, 8, 9, 10. So far we have 10 electrons. They're all happy. They have partners. But sodium actually has 11 electrons. So this guy here is unhappy. He's all by himself. So he's going to leave to go find a friend. So sodium atoms tend to lose their electrons and form what we call ions. We now have 1 more proton in the middle. There's 11 protons in the middle. There's only 11. There's only 10 electrons, which means this is going to be a positively charged electron. And what do we call positive atoms? Cations. Okay, let's look at chlorine. We've got our 2 in the middle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Chlorine has 17 electrons. So this electron wants a friend. Where is it going to find it? It's going to get it from this sodium. What happens when it does that? They form a bond. They form an ionic bond. Chemicals that are made with ionic bonds are called this general term of salt. It doesn't just mean the salt that we eat, but it's a chemical term. Ionic compounds consist of ions held together by ionic bonds, which is actually an attraction between negative ions and positive ions. What did we say the positive was? A cation. It's a negative ion, an anion. The ions stick together like opposite magnets. And in the case of sodium and chloride, they form a crystal structure. So they form a cube. Remember that the first bond we learned about, it was called polar. Polar molecules will tear apart or pull apart ionic bonds. The polar water molecule, so water has a polar bond, it will be attracted to the ions of the salt, and it will tear apart the salt crystal. And that is why salt dissolves in water. Remember, polar bonds form polar molecules, which will have a positive end and a negative end. So here in water, we have a negative end on the oxygen, positive end on the hydrogen. What type of bond holds together hydrogen and oxygen in this molecule? Polar. However, think about many water molecules. Like in a drop of water, we have many, many water molecules. What keeps them close together? What holds these two molecules together? It's a different type of bond called a hydrogen bond. So now we're talking about our third type of bond, hydrogen. Here we have two water molecules. The hydrogen end is positive. The oxygen end is negative. Opposites attract. So these two ends are going to be attracted to each other. They're going to hold the molecules together. So here's another oxygen, another hydrogen. These guys are going to be attracted. And then we're going to have even more that are attracted. And pretty soon we have a droplet of water. So remember that oxygen, that water itself, the water molecule, has polar bonds. But between two water molecules, we have hydrogen bonds. Water and hydrogen bonds. Each water molecule is attracted to 4 of its neighbors. Hydrogen bonds explain the unusual properties of water. And these unusual properties give us life. Okay, here's a quiz for you. Maybe Elio can pause and let you discuss this in class. I'm going to pause recording.